super. Hi. Huh?
You gotta remember to talk right into the mic.
Okay, Chef Arnold. Thank you. Now this is important because although I do have my voice, but not necessarily, to my normal range. All right. Good afternoon, everybody. So thank you so much for being here. Let's start. So today is Braven Talks about databases. And the title of this talk is, which should be resonating with most of the people in this company. The title is, it's not my database, it's your database, because I hear a lot is Heidi's database. So, it's not my database. It's everybody's database, and we will talk a little bit about what and why. Yeah, there will be a quiz, because you know what? Okay, who knows what was my second major? Anybody knows what my second major? Education. Okay. My second major is education, and so those who work with me for any extended period of time know that I love to teach, whether you want it or not. I kind of like force-feed knowledge, which is apparently the professional deformation, because all the teachers do this. So there will be a quiz, okay? And so now I can see that everybody here are kind of from the tech side. So some of the questions may be irrelevant. I was hoping to have people from other departments, but anyway, we will. All right. Edison, you wear a badge of honorary tech person, because you've been selecting people for us for such a long time that I am sure you yourself can now pass, my tech screening. I'm absolutely sure. All right. So actually there'll be multiple quizzes, okay? So, all right, quiz number one. You can just, I think for quiz number one, everybody in this room should raise their hands, because that's for, there was one technical talk which started from, don't worry, it's for managers. So this one, don't worry, it's not for tech people. Okay, so how many of you heard about Postgres? Everybody. Okay, good. That's what I want. So how many of you know what Postgres is? Edison, you know. You don't know? You know. Okay. Everybody knows. Okay. Everybody knows. What is Postgres? Okay. Edison, what is Postgres?
It's a data. Yeah.
Yes, it's a database. Yes.
Is it open source?
Yes. Yes. Yes.
Okay, cool. That's what
Yeah, see, see, you're verified. Yeah, absolutely. Yes. So yeah, Postgres is open source database. Also, Postgres is a relational database, and it is largely considered object relational database. And we use it because it's cool. It's like the best database, and it's open source, and we love it. So everything in this company runs on Postgres. Okay. Now, how many of you are using SQL, using SQL at work? Okay, most of us, more than half. All right, super. Next question, so that was using. Okay, did you raise your hand? Did you raise? Yeah, okay. How many of you know how to write SQL?
Good or bad?
All right. So, that's So yeah, people kind of are not sure, but if you see your neighbors raising your hand, then you're raising your hand, right? Because if my neighbor knows how to write SQL, then I know how to write SQL. No, that's how it works. My friends actually ask me, so you are teaching your finance people SQL, so do they know, is it like much, they use it, so they have to know. All right. So, now there will be a quiz number 2, a little bit more difficult, a little bit, okay? What is a database? Now we said Postgres is what is a database? Right? Anybody except Colin? Can answer? Okay, Colin, what's a database?
A database is a piece of infrastructure, well, it's a service originally, that allows you to store some amount of data. Either that data is stored relationally or not, but it's really just a way of relating and storing data.
Okay, so it's a way of storing data. Okay, any other answers? Then what do you think?
Gives you an interface to work with. It's really just files of data.
Files of data,
Customers,
okay.
loans,
Okay.
transactions, finances, whatever.
Okay. Okay, files of data. So files of data. Any other answers? Any other hypothesis? What is? Okay. Okay. Okay.
Database is something that like if it's down, everybody will panic and notice. So database, the Moravian is if it's down, everybody will notice and everybody will
Yeah, okay.
panic.
Okay, that will be the next quiz, okay? You are a little bit ahead. All right, actually, yeah, so that's why I asked what is a database. So, answer, when we say database, we actually mean two separate things. On the one hand, database is the actual data, actual volume of data which is stored on the hard drive, and also a software, database managing system, which provides access to this data. So database is two things, right? Like an electron, right? It's like how it moves and the actual particle. So database, two things, the file of data, this data volumes, and the software. So I actually meant to have this first question, what's in common between Microsoft Word and Postgres? Everything is different, right? One is open source, other is not. One is like doesn't have any data, the other does, but the common part is they both are software. Now, question number 2. Why we are using databases? And I have all reason to ask it, because just ask our finance department. They all have their little like Excels, right? Their all little files which serve them better, right? Because they know what's inside. So why we are using databases? Nobody knows? So should we not use databases? Why we use databases in general? Why that? Yeah. Okay.
Because it doesn't have the limit as an Excel spreadsheet has. So with the Excel spreadsheet can only just store so many rows. But then database is actually like much quicker, and then different people or different team can use that and start to like put on it. So that's something like really customizable, and also it's very efficient in my opinion.
Okay, so we said that a database can store more data and different people can use it and it's more efficient. Then you have something to add?
Yeah, just like over the years, people built out a lot of software and perfected it so that there's like integrity checks, quality checks. It can write the data faster than some other systems. Join data together better.
Yeah.
Thank you. Anybody has something to add about why we're using databases? Why we're not using our little files? No? Okay, so actually, no, that is all correct, and those these answers describe like the reason why we're using databases. So to summarize, as we said, database is software. So we use it to access data in most efficient way. So instead of going through our files, we have a way to access data most efficient way, the fastest way to retrieve exactly the data what we need, right? So, yeah, okay, so that's why we're using, good. Now, that's actually the brief history of data storage, why we needed to use databases. And you know what, guys, I've been through all of these 3 stages. I started with the punch cards. So when you have punch cards, you do not need any database, right? You do not need, you just actually put them, feed them in the card reader, and that's what you have. Then after punch cards, there were magnetic tapes. So data was stored on magnetic tape, but again, there was no software, there was no need for any software, because in order to write, you need actually to put the tape in. Yes, it was not only for music. I do not know, like maybe some people here already did not have your magnetic tapes to record music, but I did have these big tapes. And then you record that, and then when you need to read, you need to actually rewind this tape to stop exactly where you need and read this data, which is on this particular place. So again, there was no need to software, but then became a revolution of direct access storage. So you know what, guys, I was actually very excited when I found this picture, because it's like literally somebody asked, is it you? It's actually almost me. So that's exactly the hard drives I had in the university during like my junior, senior year, when I had my time, allocated time for like working on mainframe, on IBM 360, which was in the Soviet Union, so you know, during sanctions, so it was not IBM 360, it was like encoded is EC1033, whatever, doesn't matter. But that was like the same. So that was me having my personal disk, yes, like this size, right? Plug in this in, because when I had my time and I had to access my files, I had to take this disk and plug it in. So me, like 7 months pregnant with my older son, like, you know, doing this. Super, but yeah, that, again, the advantage of direct storage was that we had data which was stored permanently, and we do not need to rewind. We could read data from any place on this disk, and also more than one process, more than one person could read data from the same disk. So that's why actually databases started, databases emerged, because we needed software to just do something with this new option of having direct access, so have security, have concurrency control, and all this stuff. Okay, quiz number 3, and that will be the I think this will be the last one. All right, quiz number 3. So now, to your point, when you hear the word database, what comes to your mind? Like, just shout out. What's the first association when you hear database?
Eddie.
Thank you. What else? Anybody else?
A warehouse with cubes of servers. A warehouse with cubes of servers, like a data center.
All right.
Where's your running slow?
Yeah. So first, yeah, database is down. That's first thing, right? I think when you hear, that's first when you hear about database, because when everything is working, you don't hear about database, right? Database is down, that's first you hear, right? Next time, report did not run. That's the second thing, yeah, something did not run. That's again how we know something. That's when people remember that the DB team exists actually. That's when we see the messages. Hey, this report did not run today. All right. And then, yes, Bob, like, you know, the phrase of my life, the phrase of my career, database is slow. So, that's what I heard for the, you know, my 36 years in this industry. That's what I heard most. Database is slow. So now, okay, let's try to figure out why it happens that database, which is supposed to be the most efficient way to access data, why database is slow. So before going there, because I just listed all the negative things, so again, most of the time you guys don't remember about database unless something bad's happening. But I want to share some positive news about our databases here in Brevard, okay? So first of all, we utilize here number of absolutely unique technologies which nobody else uses, and I'm like serious, nobody else is using. Not in Chicago, not in the States, not maybe in the world in this combination. So we're using JSON transport objects for data exchange between application and database. We implemented full asserted versioning model that is bitemporality. We use foreign data wrappers for our ETL tool, so this combination of techniques is unique, nobody else is using it. So we are actually ahead of industry here. Also, in course of 3 years, we built completely new OLAP, which is online analytical processing, or data warehouse, and completely new OLTP database, BSF. So all this is completely new. It was, when I came here 3 years ago, there was nothing. So we built this in course of these 3 years. Our application response time is below 100 milliseconds on most of the queries, and below 1 second on update, which is way better than industry standards. So industry standard response time is like 1.5 to 2 seconds for queries. So we are like tens of times better than industry standards. And I think it's just great news, something to be proud about. And we are doing it with very limited resources, by the way, I get to say. So we are saving lots of money for the company by running on very limited resources. All right, so that's positive news about us. So now, that's what I like and kind of dislike about databases, but that's the truth. Database is way, way below of everything else. So I just said we remember about database when something is not working. Otherwise, we do not see database. Database is on the very low level. So application communicates with database, looker communicates with database. Then user interface communicates with so application communicates with user interface. So users see nice shiny interface. Users see nice well-formatted looker reports. Nobody sees the database, which is okay. So database is invisible and it should be invisible. So what I'm driving, where I'm driving for this, database is a service. And that's what I firmly believe. Database is not for me. Database is not for DBT. Database is not for the sake of being like perfect, nice, shiny, beautiful. Database is a service. If nobody notices database, if everything runs fine, that means that we are doing our job right. Database can only be like useful when somebody is creating application which talks to database, when somebody is using this application. So the purpose of the database is being a service. And our goal, the goal of DB team, is make sure that we service you better, because our customers are our internal customers. And then our customers as company, they only interact with like this outer level of this nice shiny user experience. So all of you guys are our internal customers. And our goal is to serve you better and make sure we're running smoothly and doing our best. Now back to database is slow. So if you guys are saying database is slow, it means they're not serving you better. So let's see why databases might be slow. Yeah. Yeah. Yes, now I'm going to say it's not about me, it's about you. Yeah, because like it's not happening here, but many of my other previous places of work, it was like, what application is running fine before it hits database. When the application hits database, that means start to run slow. So, what I'm about to say, it's not about database, but about how we are using database. Because database can do a lot, but sometimes no database can beat, how to put it, not perfect usage. Okay. So, I will describe two problems which are most common problems for like database usage which make database slow. First problem, it used to be a shopping list problem. I like to call it recipe problem. So what's it about? Oops, sorry. Okay. Yeah, well, okay. So recipe problem. So here's the problem. So imagine you have a new recipe, especially you are somebody like not experienced that much, so you got the recipe, maybe you're trying to make surprise for your spouse or for your mother or like whatever. So you read recipe, and you're not doing it, but that's like how lots of our programs and reports and applications work. So you read recipe. Okay, first, flour. Okay, first flour, so I'm walking to the pantry, taking flour, bringing it here to the kitchen table. Okay, next thing, eggs. Okay, walking to the fridge, getting eggs, bringing it here. Next, cinnamon. I don't have cinnamon, so I'm hopping in the car, driving to the store, bringing cinnamon. Then back to the recipe. Next, almond extract. Oh my gosh, I don't have almond extract either. Getting back to the car, getting to the store, getting almond. Then next, okay, brown sugar. Okay, that's in the pantry. Walking to the pantry. Next, butter. Okay, walking to the fridge. Okay, so you are not doing it in real life because you are not making database to do it. That's you who should do this. So because you do not want to work extra, you do a little bit of planning, right? So first you would read this recipe. And then you say, okay, this, and this, I have it in the pantry, I'll grab it from here. This, and this, I have it in the fridge. And this, and that, I actually do not have, I need to run to the store and get all those missing ingredients, right? But that's when you get to do this. So that's why, often you can hear from me, if you want to write good query, think that it's not database who will execute it, but think whether you execute it, and do you want to do what you are trying to make database to do. So if you write the query this way, that it would first go for this, then for that, then for that, it will run slow because you did not leave database any option, you did not allow database to plan how to do it better. So that's first obstacle. Second, again, used to be a problem of apples and oranges. I think two different groups are like a little bit restrictive. So let's say sorting colored balls, because at least some of you had probability theory or statistics in high school and college, so you remember you had this black box and you needed to draw the balls and calculate what's the probability of getting balls of specific color. So imagine you have this, again, black box, and say there are all the rainbow colors there, plus black maybe, and you need, so you have 3 buckets in front of you, and you need to put all reds in one, all yellows on the second, and all blues in the third. So, now I will tell you not what you would do if you would have to do it, but what your queries do. So, red, okay, here. Yellow, I'm actually collecting red now. Okay, blue, no, I'm actually collecting red now. Okay, that's red. Okay, that's green, I don't care. That's yellow again, I don't care. That's red. Okay, so you go for all the things, for all the reds, then you put everything back, and now, okay, that's blue, but I'm not collecting blue, I'm collecting yellows. Okay, oh, that's yellow, that's for me. And they're doing it for the third time. And that's the third time. Sometimes you do it like for 10 times. So the thing is that if you would have to do it, if you would not have, hey, database do this for me. Because it's a database, it can do things fast, but database also is not dealing with 100 colored balls, it's dealing with millions of records. So very often, instead of saying, hey database, I need this ones, and this ones out of this black box, deliver. You are saying, okay database, first bring me all reds, then all yellows, and then all blues, which slows things down at least 3 times, not even more. So this is another problem, and literally, I'm not going into technical details here, that's a very common sense problem, but I think database is a lot about common sense. So literally, your query is running slow, take a look, and just think, if I would be a database, would I want to do the things how I just said it should be done? That's what I'm doing, I'm always saying, I'm a database, right? So that's why, because I'm always trying to think whether I want to do things this way. And then you almost do not need any optimization theory. It's lots of common sense. Okay. Now, okay, we're a service. And we are trying to serve you better. So now, how you can help us to serve you better? Because there's just 3 people in the team, and as we said, everybody is using SQL, and most of the people think they know how to write SQL. So we need to think about what we can do to make database and database team to serve you better. So first, learn about how to write better SQL. So right now, this week, I'm actually running test class for our finance team, and we'll see how it will go. But you know what? Yes, guys, use us. You have us as resources here. You have me. Right? Francis actually asked a great thing when I introduced the courses. He asked, how much is this course? Actually, I know how much is this course because monetary value, so please use us because we're here, we're free resource, and please come to us if you need any guidance, okay? Ask, so ask if you need assistance. Do not suffer in silence. So do not think if you are running something for half an hour, it's normal because you have that much data. It might be normal, but might be not. It might be that you need just little help to make it way better. And even if like you do not care, it does not need to be done in like a minute or two. Look, marketing analytics, you guys run your models. I know you need to wait for half an hour to have it completed. You do not need, because I know how it is. You are sitting waiting, your brain is kind of like paralyzed at this moment. You cannot do anything else. You are sitting waiting. Like, help us to serve you better. You do not have to wait for so long, okay? Most of the time. So let us know, because we do not know. No, I'm always saying we created new table in data warehouse. I did not index it a lot. Please tell me what you need. Until you write your queries and tell me what you need, I cannot do anything. So be vocal. Learn, ask, and let us know if anything goes wrong. Okay? So that will help us to serve you better. So we are database, we are service, we are at your service. So please use us. Okay? Yeah. So it's your database. Please use responsibly. You know, it's with anything which has a potential. All right, so I just left this time because, you know, again, when I put together this class for the finance department, so when they reviewed my summary, what I'm going to teach, they replied, "Oh, that's exactly what we wanted to know, but never kind of dared to ask." Also, from my perspective, from a personal perspective, so I'm an active blogger in Russian blogosphere. So one of the things which popular bloggers do from time to time, they have this opening session. Everything you wanted to ask me and did not know how to ask. So anything, that's your time to ask anything you want to know about database, about database team, why it was so difficult, why things are done this or that way. Please, that's a Q&A session.
Is a shopping list problem, is that more of a reporting query or application? I think I've heard that more with.
Yeah, you know what? For the longest time, I thought it's an application problem only. But then I started to see some queries in the on the reporting side of this floor, which are exactly shopping problem. Because you know what? It's natural. People think this way. So nothing. It's not like people have this evil mind to write queries this way. It's natural. That's the way you think. But then the way you think, it's not always the most efficient way to do this. So that's something to evaluate each time you put things together. So one thing, you think about your requirements, especially when business gives you requirements. So our business, no business here, no business here, okay. No business here, okay. Business likes to give us requirements in form of SQL, and we ask to give us requirements in English language. Business loves to give us requirements in SQL because again, in this company, everybody writes SQL, right? And sometimes we just take the SQL and create a report out of it. And that's not necessarily the optimal one. So after we kind of trace the business logic, it's time to stop and think, do we really want these to be executed that way? Right? Yeah.
I don't know if this is reasonable to ask, but I think when I joined this company, I used to see something like relational, like to join different table with the keys and stuff that I think Dan put on the Confluence page. Like, is that if I want some update on that, because I know we are transferring to BSF, which team should I ask? So I think it's kind of like relational graph between different tables.
Diagram?
Yeah.
Okay.
Who should I ask?
Correct. That's actually a great question because we do not have it, and that's definitely something which you should have. The other thing I kind of like want to work at, I want to work at pre-building, and we started this work of pre-building some of the relationships for reporting, so that things which are related already like kind of combined. But yes, that is something we definitely should do and can do, and yes, let's make sure it's just wouldn't be just nice to have, but let's try to do this. I'm on board.
How's the in-memory database project going with Apache Ignite?
All right. So we okay. No, actually, again, great question because that is one of these examples when negative result is a result. So what we wanted to do, we wanted to try to start this in-memory Ignite and see whether it will help marketing analytics with some of their tasks. And so they installed it and tried, and then we worked together with the team, and we got a negative answer. It doesn't help. So, and I think it's good that we actually did and tried and went through it and said, no, unfortunately, it doesn't help. Again, nobody will ask me why you're not using Katie, why you're not using Hadoop, why you're not using Redshift.
I have another question, just so like from a user perspective, like, is there any like rule of thumb that you want us to like buy or follow to make your team's life easier? So like, is there any rules with regards to kind of like database use ethic that you want us to follow, just so that like we make your team's life easier and we make everyone's life easier?
Yes, so basically like set of rules would be like basic guidelines how to write queries. That is something which again I'm trying to resume classes because in the beginning of this company I had classes I think every 6 months or something. Then company grew bigger, I got less time, and we stopped doing it. So I am trying to like start doing these classes again. So the thing is that it's very difficult, even I'm doing it for like 30 plus years, and I've been teaching databases for 20 plus years. It's actually extremely difficult to teach something once for all, because what I experience very often, I show several techniques, and then people either not recognizing the same patterns in their real life and the abstract examples, they often do not apply the techniques which we discussed, or the opposite, when I show one cool technique, oh cool, and then I say, everybody trying to use this same technique, whether it makes sense or doesn't make sense. So now with this N+1 iteration of my classes, I'm trying to put more thoughts about like showing when any particular technique is usable and when not. So again, I'm trying not to put this like list of roles on Confluence, because it's very it's very difficult to generalize. Like with databases with all the queries, it's very difficult to put one rule for everything. So what I'm trying to teach, I'm trying to teach the approaches. If something like this, try this. If this doesn't work, do that. Because otherwise, I cannot, like me, Tejas, Sudhir, we cannot literally like evaluate and monitor each and single query, because there are more of you guys, way more than us. That's what I'm trying. I'm trying to teach the technique, I'm trying to teach the approaches, I'm trying to teach these ways to evaluate. And sometimes it cannot be improved, so that's the thing. I'm not saying that each and single query in the universe can be optimized to run very fast. But we can use different approaches. You know, one thing now I'm saying, when you create a new report, please consider refreshing in increments. Because long time ago, you know, when I started, we have 5,000 loans in LoanPro. Can you believe it? We had 5,000 loans in LoanPro. Now we have like 365,000 loans, I think, as of today. So then it would take me 5 minutes to fully refresh the whole data warehouse for LoanPro, like 5 minutes, 4 minutes actually. So now it's not the case. Now we have more data. So now each time when we create something, we probably need to evaluate. Okay, now this particular report has very little data. How it will behave later? What is the expected growth? So can we start doing it in increments from the very beginning? So that is something I would love to discuss for each and single new project. Okay? So like as I said, I cannot and I do not think it's right to evaluate and to like sign off on each and single report and each and single query, but please pull us in when you're starting something, when you want just to discuss whether what you're going to do makes sense or does not make sense. Because then we know we can help and we can like suggest something else, something new. Okay? No? Jim, how did you like the class? All right? Thank you.
Thank you.